Welcome to lesson 5.3, graphing quadratic inequalities in two variables. So in this lesson, we're going to take what we learned in 5.1 on how to graph quadratic inequalities and what we learned in 5.2, working with two variables and put them together. So we're going to graph quadratic inequalities, but since it's in two variables, we're going to use the fact of what we learned in the linear part, such as the dotted line and the solid line, to graph our parabolas. Go through the information that we need to know and then dive into some examples to apply them. So we got a quadratic inequality in two variables can be written in general form as so. So similar to before, we have y greater than ax squared plus bx plus c, and then we're going to have it less than, greater than or equal to, and less than or equal to. So here again, a, b, and c are all constants, and a cannot equal 0. The graph of a quadratic inequality is all the ordered pairs x, y that satisfy the inequality. So since we're in two variables now, we have ordered pairs x and y. A note here that we need to make sure we're aware of. In a quadratic inequality, the solution is either above or below the parabola. So this is where we're going to have, it's similar to the last lesson where we need to graph our inequality and then test a point to determine whether we shade above the parabola or below the parabola. So let's do an example to see what we're talking about here. Graph the inequality y is less than 3x squared minus 4. So first of all, I noticed that this is in standard form, and hence we can go ahead and graph that accurately. So for now, when we're going to graph it, I want you to ignore this inequality. So let's look at the fact that it's y is equal to 3x squared minus 4 to go ahead and graph it. From what we remember in Unit 4, we have a vertex here, now at 0, negative 4. It's going to stretch by a factor of 3, and it's opening up because it's positive. So from there, let's go ahead and graph it. We have our vertex at 0, 4, 0, 1, 2, 3, negative 4. Our vertexes are right around there. Now usually we would go over 1, up 1, but since we're getting stretched by a factor of 3, we go over 1, up 3 on both sides. And from there we would go over 2, up 4, but now we're going to go over 2, up 12, which lands us right about here. So from here, I would go ahead and connect my points to get my parabola. Now this is where I'm going to come back to the fact that we have an inequality, and it is a less than. So from 5.2, we found out that when it's less than or greater than, we use a dotted line. So same for here, we're going to use a dotted line. So connecting to get our parabola using our dotted line looks something like that. Okay, so now our next step in graphing our inequality, we used our test point. So since 0, 0 isn't part of the graph, we can test it. Plugging it back into our original, we get that 0 is less than 3 times 0 squared minus 4. Solving, we find 0 is less than minus 4, which is not true. That is not possible. So since our test point that we used was here inside of our parabola, that means we need to shade the opposite. So we're shading outside or below the parabola. So we need to shade all of this area here. Those are where our solutions lie for this quadratic inequality. There we go. That's exactly what we're going to be working with in this unit. Let's do another example. Example 2. Two numbers are related in this way. Sum of 2 and 3 times the square of one number is greater than or equal to 5 minus twice the other number. And then it wants us to graph the inequality that represents this relationship. So first of all, we need to figure out what this relationship looks like. So we have two numbers. So we need to let, say, x equal one number in this case, and we'll let y equal the other number. So the sum of 2 and 3 times the square of one number. So here we have the sum of 2, which means we have 2 plus something, and then it says 3 times the square of one number. So it's 3 times, well, one number is x, and it's being squared. And then from there it says is greater than or equal to. So greater than or equal to, and it says 5 minus twice the other number. So 5 minus 2 times the other number, which is y in this case. So our relationship looks like this. So in order to graph it, we need to put it back into our standard form. So let's do that. Rewriting here, we're going to get 2y on this side greater equal to negative 3x squared plus 3. Now solving for y, everything divides by 2, and we get y is greater or equal to negative 3/2 x squared plus 3/2. So in this case, I would factor out the negative 3/2 and leave us with x squared plus 1. So when looking at graphing this, I would have now a vertex of negative 1, the opposite sign here, 0. It would open down because we have a leading negative here. It's being stretched by a factor of 3/2. So now that gives me enough information I could go ahead and graph it. So our vertex, negative 1, 0, is right there. And it's going downwards, being stretched by a factor of 3/2. So instead of going over 1, down 1, I would go over 1, down 1.5. And then instead of going over 2, down 4, I would go 6. Over 2, down 6. Somewhere like there. And then from there, I'll just continue growing. So when I'm connecting my dots, I'm going to use a solid line because it's a greater than or equal to inequality. So I'm going to get something as so. Awesome. So to finish it off, I need to test and see where I need to shade. So 0, 0 is our best test point here. Plugging back into the original, we get 2 plus 3 times 0 squared greater or equal to 5 minus 2 times 0. Well, here I'm going to get that 2 is greater or equal to 5, which is not true. So I would shade the opposite area where the 0, 0 is. Well, since 0, 0 is here, I'm going to shade inside my parabola. So my solutions are now below. Cool. So B is asking, use the graph to list a pair of integer values for the two numbers. So our possible solutions we determined were within our parabola here. So we could just choose any point in the shaded region to represent our two numbers. So for example, a point in the shaded region is negative 1 and negative 1. Another point could be negative 1 and negative 5. And the list just keeps going on and on. There are many possible solutions that we could choose from. So those are just a couple examples. Excellent. Great work.